For this presentation, I'm going to go through a quick a walkthrough of a PowerPoint real quick that just touches on things on a high level, and then we'll sit down and actually get into the using the software and doing a few walkthroughs of different features and analyses that are available in the software package. So for this presentation, I'll give you a little bit of background about our company and our software. We're going to really focus on HECSTAB and HexTab, and mainly on the HexTab portion of things. We'll go through some definitions of what it means when we're talking about a condition and a calculation. And then some of the new things for those of you that have used HexTab or our software in the past. We'll talk what's coming in that's new, analysis packages and templates, our reporting capabilities, and go through just try to touch on as much as we can on a high level on what's new in our software package. So a little bit of background about us. Herbert-ABS is a joint venture between Herbert Engineering Corporation and the American Bureau of Shipping. We focus primarily on leading edge stability, load management, and salvage software for the marine and offshore industries. Our main office is located in the San Francisco Bay Area, but we've got worldwide coverage basically with satellite offices in Houston, Annapolis, Glasgow, Singapore, Busan, and Shanghai. We've arranged this webinar to be on a Euro-friendly type of time zone, so it's a little bit early here for me. I'm hoping that for most of you it's not too early, and it's a reasonable time. We do have some of our European engineers here, as well as a couple of our US-based engineers as panelists as well. So just a quick overview. We have basically 4 main packages of software that we can provide: HECSTAB and HexTab, which are kind of generic, high-level type of software packages that can be used for stability analysis and calculations. And then CargoMax and LMP, which would be our one-off kind of software designed to be used on a specific platform or on a specific ship, customized for that ship to be used in day-to-day load management and stability calculations. For HexTab, this is our newest package, and it's basically our software package for naval architects on the design or evaluation side of things. So it contains a number of tools and a number of applications that can be used for vessel modeling and engineering, designing and refining a model or a design and doing calculations, and then focusing on regulatory stability assessment, making sure that all of your stability regulations and requirements are being met, that your design is meeting all the requirements that are necessary that it needs to be applied to, as well as providing tools and reports and documentation that can be used to put together TNS booklets or loading manuals or stability documents or things like that. So the HexTab package is one side of our package focused on basically design and engineering. On the flip side, HexTab, which many of you may know before or have heard of before, is kind of the flip side of the coin, and it's the software package that we provide for naval architects and salvers. It's got the same basic modeling and engineering capabilities for putting a vessel model together, but a lot of it's more focused on emergency response, doing calculations to make sure that in the case of a salvage and emergency, that engineers or salvers or people that are responding to the emergency are able to perform calculations, perform predictions, and to mitigate casualties and damage, things like oil outflow and things like that. So the HexTab and HexTab, like I said, it's kind of two sides of the same coin. A lot of the tools and a lot of the calculations are going to be the same, but it's just, which way is the package focused? Is it focused towards design versus is it focused towards emergency response? So for this presentation, we're mainly going to be focusing on HexTab itself, as that's the newest software package that we have available. And we'll be talking through what is new and what we can do and what's kind of coming down the pipeline. For those of you that have used HexTab in the past or have seen our software or have seen what we can do in the past, this presentation will be touching on a lot of of the old things, but mainly we're focusing on the new stuff. So there's not going to be a lot of discussion on our modeling situation. That hasn't, our modeling tools and things like that have not changed appreciably. We're mainly focused on the new user interface and the new tools and methods and analyses that we have available in the package. So for HexTab ships, for example, we can do a wide range of different types of analyses. We can do, basic, straightforward deterministic analyses. Given a ship design, given a writing arm criteria or a set of criteria, you can determine a maximum kg curve or determine the feasibility or the applicability of certain loading conditions and things like that. We can do more advanced probabilistic analyses like those defined by SOLAS, looking at a wide range of possible damage cases and making sure that the overall survivability of a design is being met. Basic intact and damage stability calculations, as well as doing things like the standard ship documentation and tables. As a designer, there's a lot of documents and a lot of information that needs to be put together to be used and approved for a vessel, loading manual and TNS booklet being one of the main ones. HexTab is very focused and very capable in assisting in putting those documents together. And then finally, putting actual sample loading conditions together. Again, something that would go into a loading manual or TNS booklet. We can assist in putting those together and making printouts and results for those loading conditions as well. On the offshore side of things, there's a number of additional features that we do for the offshore market. We originally kicked off this HexTab, this new version development, with the expectation and the drive from ABS to have a new tool for them to use in-house as their offshore vessel review program. So we've spent a lot of time with this, working with ABS to make sure that from a regulatory assessment standpoint, it's able to calculate and verify, a number of offshore designs that might be coming in from other designers or from other programs that they'll have to then verify using our software. We've made HexTab itself very flexible, and it's not, by any means, it's not limited to just ship-shaped vessels. We can do analyses and we can do calculations for anything that floats, basically. Anything that you can define a model for, anything that can be floating, we should be able to do the calculations for it. For offshore focus, that means that we're still looking at things like intact and damage stability, but in this case, we're actually looking at free to trim. We can look at stability along any axis. And a lot of times when you're looking at offshore vessels, you're looking at stability, a full 360 degrees around the vessel. So we are, and we provide tools for simplifying and standardizing that type of calculation and approach. We also have the newest methodology for evaluating offshore stability, which would be the free twist approach, where it's actually looking at the path of least resistance and allowing the vessel to actually freely rotate as it's being heeled over. So what's new? We have put a lot of effort and a lot of manpower into upgrading our user interface. And again, for those of you that have used our software package in the past, if you've used HexSalve or CargoMax, HexTab is going to have a lot of the same features and capabilities as you're used to, but it's going to be different in a lot of ways, and hopefully in a lot of good ways. So one of the main things is we just needed to get our software up to a modern programming environment, which allows us to do things like multi-threading, which will greatly improve calculation speed. We can also, we're also working now off of a database, so we have much improved handling of large analyses. We can load up and do analyses with thousands of conditions and automatically create those and run those, save those, load them up, and everything is a lot quicker because we're working off of a database. We've greatly increased our capability for tracking the changes and we'll look at this when we get into the condition definition, but tracking what's being changed on a condition and how that information and those settings kind of filter down to subconditions. And then these next two items are one of the strongest features, I think, of our new software is we've really made it as flexible as we can so that and our users can use the software to do any number of things. So we've done basically two main things. We have a very clearly defined programming interface that would allow a person or an engineer, a user of our software to be able to write scripts or tools that can use HexTab to do calculations in a number of different ways. And we do provide a Python scripting interface to support that. Again, when we get into the hands-on, I'll show a number of ways that we can kind of leverage this API and the Python scripting interface to do some really cool things with our stability calculations. Finally, we've also done a lot to improve the reporting capabilities. For those that have used HexTab in the past, our reports are very nice, I believe, but they were not customizable. We were giving you one report for a TNS summary or one report for a weight summary, and there wasn't a lot of ways to modify it or customize it for what you need. With the new package, that's now very flexible and very open for changing. And we'll look at some of the different examples for the reporting capabilities as well. And then at the bottom of the list, we have actually implemented an undo redo feature. I know that's always been a sticking point for some people. So we do have some ways to go back and undo and redo things as we're using the new user interface. This next slide is a kind of just a top level flow chart or kind of data flow of how our package works together. On the left-hand side is the design side, basically, ship project editor. This is our standard modeling software. This has not changed. If you've used HexTab in the past, the ship project editor is going to be what you're used to. We are working on expanding and enhancing our support for external other types of modeling software. We've done a lot with integrations into Rhino, for example. We also have a number of ways to import models from other stability software out there. And using Ship Project Editor, you can do a number of reports coming straight out of that tool. But then once you have a model defined, then you can use that in HexTab itself to do any number of analyses. And we'll look at a number of those here in this presentation. There are a lot of things that can go into an analysis. We've got a number of tools for putting criteria together or for putting Python scripts together or some predefined analysis templates that we can provide or we do provide with the software. Have all those being run in HexTab, and then from that you can then use the report designer or our included reports to print out the end result of whatever analysis it is that you're doing. So the main interface, again, we'll look at this a bit hands-on here in a second, but just to show you, for those of you that have seen HexTab, it'll look a little bit more modern, a little bit more up to date. We have a modern ribbon bar, for example. We've got a main workspace with a condition tree. We have a number of graphical displays that you can look at to get a visualization of the condition you're looking at. An entry forms for entering the definition of the condition, entering weights, entering condition calculation options, things like that. And then a number of ways to actually look at the results, to look at your writing arm curve, to look at your strength results and things like that. So when we're looking at HexTab, the main thing to be aware of, especially for those that have not seen our software in the past, the main idea behind our software and our evaluation is you start with a model of a vessel floating in water, and then you define a condition. So a condition is going to represent a single analysis, a single snapshot that we can then calculate and predict what we would think the drafts would be for a condition. We can evaluate that condition for a number of different ways, for writing arms, for strength, and things like that. So at its very basic, using HexTab, you want to define a condition, run the condition, and view the results and view the analysis of that condition. A condition can have one or more condition tools applied to it. So these tools can be used to affect single conditions, or they can be used to actually start with one condition and create a number of sub-conditions underneath of it. So for example, you can have a simple tool that just says, hey, give me a condition that gives me a draft of 10 meters. or give me a tool that will evaluate this writing arm criteria, this GZ criteria, or give me a tool, apply a tool that will take this condition and modify it such that I can find the maximum kg or the required GM, that type of calculation. Or you can have a tool that does something like creates multiple off-axis headings. So I can say, here's my starting condition. Now give me, 15, 20 conditions that are based on this condition, but looking at the stability at every, 15 degrees around the heading, that type of thing. And then finally, what's really powerful about HexTab itself is the idea of condition hierarchy. So when you're putting an analysis together, you might want to define something where you start with an intact case and you define your starting condition as an intact condition. And then you can do a subchild. It's basically, we're looking at this as a inheritance type of situation where you have a parent condition and then it has a child condition underneath of it, and everything inherits down to the child. But then on that child, you can make a change on that child to say, okay, for this case, let me change the heel axis, let me change the damage setting, let me change something else, and everything will basically flow down through the tree, and you can very simply and very quickly kind of simply define an analysis by setting these changes on the children as it passes down through this hierarchy. And it's really nice to be able to identify where you've made changes and what conditions are to kind of build up an analysis. So you can see the difference, what changes are being inherited from the condition above versus what changes have been set on that condition itself. Some of the other neat things on the HexTab side, on the offshore side, I've talked about this before. We do have the capability to look at things in a free trim or a free twist type of methodology. The free trim is the conventional approach. You basically specify, give me the stability around this healing axis. For an offshore, for a ship, that would normally just be the longitudinal axis. For an offshore shape, you might be looking at multiple headings where you rotate around the entire vessel. The free twist method is the newer approach, and it represents the path of least resistance, where it will allow the vessel to rotate and kind of find the natural rotation as you apply a moment to the vessel, how it would actually rotate as well as heel over. Another nice new feature with the new package now is the idea of an analysis template. So we have designed HexTab to be very flexible and to do, any type of calculation that you want. But in reality, a lot of analyses are going to be very cookie cutter. You'll be doing the same things for different models, but the same basic approach. Looking at putting together an intact required GM curve or damage stability required GM curve or something like that. So in cases like that, we basically designed it so that we can make an analysis template for that approach that will basically walk you through the basic steps to do that analysis. So you only have to enter a very small number of entries, make very few definitions, and then the analysis template will go through and actually create the analysis, create all the conditions for you, and allow you to very quickly do that analysis. So for example, this would be something like a SOLAS probabilistic type of analysis. We can have an analysis package where we have a whole new ribbon bar added in. We can have analysis templates that will walk you through the process of doing a SOLAS type of, or like a regulation 7 analysis for cargo ships or for passenger ships. And then that package itself can have a number of commands or tools to view information or change things. It can have any number of tables or criterias or documentation. We'll look at this in the interface again, because it's one of the main, what I think is one of the main strong features of the HexTab package itself is this an idea of an analysis package and an analysis template to walk you through doing the standard types of analyses. So here's an example of walking through a SOLAS analysis. You have kind of like a wizard along the left-hand side where it has basically 5 steps. It walks you through it, and you define those 5 steps, and everything else outside of that, HexTab will take care of for you automatically. We'll go through this process here in a bit. And then on the reporting side, we have greatly improved and enhanced our reporting capabilities. We actually just rolled out our newest version, which we'll be releasing, I believe, today. We've actually added a second way to do printing and custom reporting now. So the HexTab analysis and projects and the analyses itself are stored in a database. And so now we actually have a database reporting tool built in where we can provide some standard database reporting templates for doing things like weight summaries, TNS summaries, direct damage stability summaries, things like that. But it also just allows you as a user to customize that report to give you the exact report that you want to see. And it's all based on kind of standard database reporting. If you've ever done database reporting for other software, what you'll see here will be very similar. What we've also just rolled out is actually taking a Python scripting approach as well. So if you don't feel comfortable with the database approach, but you have a little bit of Python capability, you can look at our Python scripts, and it'll basically allow you to lay out an entire report, to put tables in certain locations, set your header and footer, set your tables, add page breaks, add table of contents, cover pages, and things like that. So again, a lot of flexibility that we've added to the software on the reporting side. Looking forward, we are trying to build a community of HexTab users, and our idea is to have an online forum to share knowledge and solutions, have some message boards for answering questions, as well as maybe allowing people, ourselves and our clients, to say, hey, here's a GC criteria that I thought was neat that I put together to address this certain thing, or here's an analysis template for doing this type of analysis that we did. Here's a customized report that we put together. Here's a Python script that we put together. So we're still kind of cultivating this and kind of building this up from our user base, but we do hope that as we build a client base, that there'll be a lot of good knowledge being shared and passed around. And then looking forward, what does the future hold for HexTab? We will be actively developing on this for the foreseeable future. In the short term, we're working on the direct calculation of wind over turning moments, being able to define not only the underwater portion of a hull, but to define the superstructure and the components that are on top of a vessel to allow you to calculate the wind moment directly from that definition. In addition, there's a number of new dynamic stability requirements and evaluations that are kind of in the works as well. We're looking at implementing those. We're looking at integrating a lot of our more advanced features from our onboard loading systems, CargoMax and LMP, looking at things like detailed container buildup and tracking, or advanced time domain sequencing, detailed deck cargo tracking, and tools like that. So that's my very quick spiel for the presentation, and what I'd like to do is just jump straight into running HexTab itself and kind of walking you through the new user interface, and then we'll look at a couple different evaluations, a couple different analyses that we can do. So to start with, I'm just starting up HexTab. It's showing up on another screen. I'll bring it over here as soon as it's done. All right, so here is our main HexTab user interface. For those of you that have seen the software before, it'll look a little bit newer. Obviously, it's built on kind of modern conventions. It's got the main ribbon bar across the top that's very customizable. We'll look at a number of ways that we can customize this, but you know, if you've ever used Word or Excel, you'll notice a lot of the same conventions and a lot of the same capabilities here. Adding buttons to your quick access, hiding the ribbon bar, having kind of dynamically created ribbons as they show up, and as you click on things, having buttons and items show up that apply to that. So, you know, here I've selected on a tank, so I get a new edit tank ribbon bar, for example. Just a lot of customizable and useful user interface improvements along those lines. We have our standard back page. Again, this looks kind of straight out of Word or Excel, where you can open, load, save, print, import, export, you know, all those types of file type of actions. We're working off of a new file format. We call it a HECSTAB project, an HPR file. So as you put an analysis together, you can save an HPR file, and it will, you know, you can save that and come back to it in the future, and everything will come in automatically for you. So I said the ribbon bar was customizable. I have it, you know, as I click on something, I get it, it customizes. It's context sensitive. I can also add ribbon bars. So if I add an analysis package, again, we were looking at that SOLAS analysis. If I add the SOLAS analysis package, I get a whole new ribbon bar up here that gives me my SOLAS and all of the tools and commands or reports or whatever that kind of go along with it. And then in the main user interface, the workspace itself is very customizable as well. So I have a very simple layout that I've shown here. I've got my condition viewer over here on the left-hand side. I've got my results bar over here on the right-hand side. I'll do a quick calc and just get some numbers showing up here. You'll notice that I have basically defined it as I have my definition here at the top, so I can set my calc settings, I can set my loads or my weights, and then down at the bottom I kind of have my results. So here's a weight summary. I've basically just got 1,000 tons on this one. I've got a TNS summary that gives me my results. You can move an item in and out of a thing. So if I think I accidentally clicked and dragged this tab, so it actually popped out, and it's showing I can move it on another window. I can, if I'm interested in this, seeing this report always, I can put it someplace I want it. I can, you know, reassign it to a window, so now it shows up in a tab up here. I can also change how I see it as well. I can add it as a sub window on the side. So there's a lot of flexibility when it comes to setting up your workspace and setting up how you view information and how and where you can see things. So we've tried to make this as flexible as possible to allow for, you know, everyone, you know, wants to look at things a little bit differently. So we have built-in 3D graphics. So in this case, it might not be apparent, but I actually loaded up, I didn't load up a ship. I loaded up a model that came in that was just basically our Herbert-ABS name and defined in a 3D model. So again, kind of just showing that we can, it doesn't just have to be a ship shape. It can be anything that you can define a volume for. We can do the stability calculations on it as well. So you can have floating windows, sliding windows, you can rearrange, you can move things around and customize everything as you want. If you close HexTab and come back, obviously it's going to save it as a workspace, so it'll save those settings and everything will come back in as you last saw it. So very basic, very straightforward, but we think it's very powerful and like the look and feel and the modern enhancements we've done to the software package. So moving on to a little bit more complicated, we'll look at the actual condition setup and do a little bit more of a detailed analysis here real quick. What I'll do is I'm going to load up a semi-sub example. So I have a semi-sub model here that I'm going to load up that I've put together a project for, an analysis for already. So I'm loading up HexTab. I've selected my model to work with. That's the semi-sub model. If I look at a 3D view here, you can see it's a 4-column kind of symmetrical offshore platform. And I can go File, Open. I can open a project, and I'm going to pick my this analysis here to start with. And I'd like to spend a little time just going through the condition hierarchy as I talked about in the presentation. So you can see here on my Condition Explorer, I've got a little bit more of a tree showing up here now. So I've got my start condition, and then I've added a child under it that I've called LC1, loading condition 1. And then from there, I have a sub condition called DDS base. And then under that, I have, I don't know, 15, 20 different cases. And so what I've done here is basically done a very simple one condition direct damage stability analysis. So here's where things get interesting. So I can say on my loading condition 1, I can look at my local changes here and I can see, okay, on this condition, I've set all of these things. I've basically defined the wind source. I've set my tank filling levels for these tanks. I've set the percent full to 1 for all of those. Looks like I set some volumes. I set percent fulls on some other tanks. And so, and I applied a writing arm criteria. So that was my definition for my loading condition. And then I go down to my DDS base, and I've added a new tool here. I've added a DDS, a couple calc settings for sea density and intact mode. And I've applied a damage stability criteria. So this is kind of inherited down. And these are the only things, everything is the same as LC1, except for these 7 things that I've changed here. And then under here, if I look at my first damage case, here's where I've gone through and said, okay, in this case, I've set my intact mode for all my tanks. And then down at the bottom, here's where I've damaged my 1 tank, and then I've set a number of direct damage stability settings on this. So everything is kind of inherited down, and then as I look through my damage cases, they're all kind of the same. I've inherited everything, and the only thing that's really changing is going to be, you know, what my damage settings are or something along those lines. So this tree allows for a lot of flexibility here that allows me to do things that might have been a lot more difficult or a lot more time consuming on the old HECSTAB version. So for example, if I just wanted to start with this loading condition and make some changes to it, I can duplicate this, and it'll actually give me this loading condition 1 plus everything else under it. So everything here is set up. You'll notice that I have green icons up here. This is indicating that these conditions are run. There are valid results for it already. In this case, it's new conditions. There's nothing showing up in the icon. This means that these conditions would have to be run before results would be available. But for this loading condition, I could say, okay, in this case, I want to do the same analysis, but for this loading condition, I want to just, on my ballast tanks, I want to see what would happen if these tanks were 50% full instead of 100% full. So in this case, it's basically everything is set up the same as it was in my previous condition. I've changed my starting condition, but all my sub cases, all my damage settings, everything under it is gonna flow down through it. Another nice thing while it's doing this calculation, the user interface itself is multi-threaded. So as calculations are going on, I can still click on different conditions and look at the results as they come in, as they become updated or refreshed. So a lot of times the calculations, especially if you're doing a large analysis, the calculations can take a little bit of time to go through everything, but it doesn't lock you out of looking at the UI and at least looking at things while those calculations are ongoing. So we can see here on this case, for damage case 1, I have my 3D view I could look at. I have a TNS summary that I could look at that would give me my calculated drafts and trim and stability. I have my writing arm curve that I can look at. Here's my writing arm curve for this damage case. And I have my alarm summary, and here's where I can actually look at, you know, in this case, I'm doing a damage stability criteria based on MODU for column stabilized units. And I can expand this and actually look at the writing arm evaluation. I can see my healing arm, I can see my GM, I can see my down flooding angles. I can look at my equilibrium angles and my evaluations, my first intercept. Like, so for this case, I'm actually evaluating these 5 things: my angle of first intersect, my must be watertight to first intersection, maximum healing arm and GZ ratio, things like that. So that's all kind of built into this analysis and what the results are I'm looking at. So it's run through and basically rerun all these conditions here. I can copy, I can paste, I can rearrange things, I can clear. It makes the user interface a lot easier to set up an analysis. So if you know your damage cases, but you have 10 or 15 conditions, you define your conditions by themselves, and then, you know, just copy the damage cases underneath of them, and everything from your parent condition will flow down, and the only thing that'll be overwritten would be, you know, the individual damage definitions or calculation settings and things like that. Once this is done, we can also kind of look at ways to look at reporting. So if I go to File, Print, I have my options to look at reports. If I wanted to, I could do a simple report to just look at my damage cases, for example. Here's, I picked the condition that had all my damage cases underneath of it, and here's just a basic printout of the damage case definition. Same thing again, if I wanted to look at the compartment permeabilities. If you're putting together a damage stability booklet, these are types of things that would need to go into that booklet to say, hey, here are my analysis calculation settings that I used. But you can also do things like look at the direct damage stability summary. So in this case, I can kind of have a one-line summary where I have all of my results kind of in one place, set up as a table saying, yes, everything, here's my load case 1, everything passes under that. Here's my load case 2, everything passes under that as well. I can add a report using, so these are using the database definition or templates basically. We can also do the same thing with a Python script as well. So I can look at the direct damage stability here, Python script. I can pick the condition I want to use. I'll pick my top level, just LC1 here. And if I reload this, so in this case, the Python script is actually set up to add a table of contents in this case. So it's it's showing a table of contents, and then it's got a legend that is basically saying, here's what's being shown in the table, and then here's the actual table, here's the cases. So again, it's the flexibility and the power of this reporting, I think is quite interesting, and one of our stronger features with the software package. We talked about earlier in my presentation, we talked about adding tools and doing things on a case-by-case, on an analysis, or on a condition tool basis. So in this case, for example, I can add just a new child here. I'll skip the damage stuff. I'm just going to add a new condition. I'm going to call this stability surface. So this is a tool that I can run. If I click on this, I go to my tools and I can add a tool. I have a whole list of possible tools that I could add here. But one would be like a stability surface plot generator. I can add this, and this is going to basically give me an analysis that will look at the writing energy around on a matrix of heel and trim. So I can run this, and it'll basically show you how the stability, how much energy it would take to move or to rotate or to heel over in a number of different directions. So in this case, you can see, the stability is going to be the low point, and the force or the overturning moment would push you in one direction, kind of to the lower area. So just a quick example of one type of stability or one type of condition tool we can add. Another condition tool that we can add. So looking at this load case on the intact side, this has an intact requirement here that's looking at the writing arm curve, and it's looking at a healing area ratio. And sometimes maybe on a design side, you might want to say, this area is being limited by the down flooding. So in this case, I've got a ratio of 2.1, which is much more than my 1.3 requirement. So the question is how far over could I get before, what's the minimum angle that I could heel over to that I would still pass this requirement? So in this case, I'm going to add another child here, and this would be, I'm going to call this dynamic angle. The idea here is that I can add a tool. I'm actually going to add a Python script, so I can actually write this tool myself to say, give me the code, or give me the, I've written a Python script that gives me the algorithm that says, let me just load it up here real quick, dynamic angle to meet angle. So it's basically just, it's walking through, doing a quick iteration to try to find where that ratio is going to just meet 1.3, the ratio angle basically. And I can run this. So if I run this condition now, in my alarm summary now I have a new item that I've added kind of programmatically using that Python script to say the dynamic angle here is 18.4. So in this evaluation, my down flooding angle is 27 and I'm passing this criteria. Even if my down flooding angle was 18.41, I would still pass this criteria. So it can be useful for things like that. There's an infinite number of ways that you could use this Python scripting tool to kind of do an analysis on the fly, or to do a sub-analysis on a condition to find a certain piece of information, or something like that. So I want to switch over to another project that we have here, just to show some other things. I'll do this semi-sub intact off-axis with max kg. So here's a case where maybe I've put an analysis together where I'm looking at trying to make a maximum kg curve based on damage stability, looking at multiple drafts and looking at multiple headings, looking at as it rotates around the platform as I heel over in different directions. So I've basically set up a draft of 30.18, and then under that I have healing axis where I'm going 0 to 180 basically every 15 degrees. And I'm finding the maximum kg, I'm finding the axis where the actual the worst maximum kg is. In this case, it looks like it's this 135 heading angle. This is where my maximum kg would be limiting. So I can set up this analysis pretty quickly on my draft itself. I can do an adjust water plane to say, give me this draft, and I can go through and set these up, copy paste, set things up, and run the analysis, kind of do it all by hand. But what's more interesting would be having an analysis template that just kind of walks me through this directly, which is what we've put together with an analysis package. So if I go to my analysis package templates, I can add an off-axis max kg. In this case, I have an analysis, so it adds a new ribbon bar up here. I have an intact max kg or a damaged max kg. I'll just do the intact one to simplify things. But if I click on this brings up my wizard, my walkthrough that gives me, kind of saying, here's what this analysis template is going to do, and here's what you're going to get out of it. And it gives me the 5 steps I need to do. So I need to define variables. In this case, I'm just going to I'm going to make it so it goes a little bit faster. So I'll just go 30 and go to 180. I can specify what my stability angles are. So here I was doing a lot of writing arm criteria. Again, I'm just going to make this a little bit quicker. So I can just do 0 to 50 every 10 degrees. I can define my wind. I can do a table lookup. I could do the direct calculation we talked about, which we're adding. In this case, I'll just use a user-defined moment just to, again, simplify it and give us a quick result. I can select my criteria. So in this case, I'll browse and I'll go to, I'm just going to use my standard intact, my Modu intact stability. I can add that. Define draft set. Again, here I can enter in my name and my drafts. I kind of have it set up over here where I can just copy and paste it. Again, just to speed things up a little bit. So very quickly, I've set up a very basic intact maximum kg analysis, and I can run this analysis, and it's going to basically clear out my previous condition. It's going to set up my individual drafts. So you'll see here on this draft, I've added the one tool here is going to be the adjust water plane tool that gets me to the draft I've specified, and then it's added the heel axis evaluator condition tool under it, so that when I run everything, it's going to go ahead and basically add that as it goes. So here you can see it's run one calculation. Now it's adding the different headings, making my sub conditions underneath of it, and it goes through and does that for each of the drafts I've defined. So, if I was doing one intact stability analysis, I could set it up by hand. But if this is something I'm going to be doing on a regular basis, it's something where I can set up the features, I can set up the steps and the entries that I need to do in order to kind of simplify and standardize that process. So HexTab comes with a number of these templates included with it, but our thoughts is that, as people use and customize the scripts or use the software themselves, they can come up with their own templates and modify, enhance, improve them as they go along. So I think that was everything I wanted to show here on this condition. Oh man, I'm running out of time. Let me go ahead and stop this. I wanted to touch on a different analysis as well. Again, just kind of to walk you through a little bit more of a more complicated type of analysis. Even those, we can put a template together and kind of walk you through the basic steps. In this case, I'm going to look at a container ship. So in this case, we're looking at a container ship where we've done a SOLAS Regulation 7 probabilistic damage stability analysis. So I'm going to open the project that I've already put together for this guy. So full run SOLAS 2 V1 Reg 7. So you'll see it's loading up. It takes it a couple seconds, but I always like to start with this. You know, it's basically got my SOLAS Regulation 7 parent condition, 3 drafts, and then under each draft I've got a whole lot of damage cases. So in this case, this analysis itself, if I look at my summary, I've got 1,500 damage, you know, a total conditions basically in this analysis. So I like to show that off just because it, you know, it basically took no time to load up. It's got everything defined. It's got everything here in my user interface very quickly. I can easily swap around and move around within the analysis as well. So this was put together using our analysis package for SOLAS, and if we look at the template that was used for this, it's the same kind of layout. It kind of gives me my description of what's here and what I can use, you know, what steps I need to go through to do this analysis, and then it kind of just walks through me, so I can define my subdivision draft if I want to do port or starboard or both, or what my B calc intervals, you know, customized for this type of analysis. The zone boundaries in this case is kind of where a lot of the heavy lifting is done. This is what's being used to define how all of the damage cases are going to be created for this analysis, kind of showing the logical breakdown of the longitudinal bulkheads, transverse bulkheads, and things like that. I can specify what heeling axis and what, you know, riding arm angles I want to look at. I can specify my permeabilities that are being used. In this case, it's interesting because the permeabilities for certain things can change based on which draft is being applied. So I think if I go down here, if we look at the dry cargo, the permeabilities will change for some of these things as they're applied to the analysis. And then finally defining the draft set itself. So in this case, we've defined our deepest draft, partial draft, light service draft. Everything is set up. So I'm going to run this again just to kind of show you through. This is showing me the probability for each zone. If I hit one zone here, I get 40%. If I hit 2 zones, again, this is all just kind of focus on this analysis. But to simplify it, I'm just going to do a one zone approach. It's going to clear off my previous analysis, and now it's creating all of those damage cases. It's creating those drafts. And it's basically set up that whole evaluation in a very, very short amount of time. And if I run this, in this case, I've only done one subdivision, so I end up only with 350 damage cases. But I will run this real quick. I need to make one change. If I run this analysis while it's going, you can kind of see how fast it goes. For these calculations, it's actually quite rapid. It goes through and does the calculations quite quickly. If I click on something here, I can see my evaluation for my SOLAS. Here's my riding arm curve, my evaluation, my S-final calculations. Those of you that have done a SOLAS analysis, these things might mean something to you. Otherwise, it's, you know, it's just an evaluation of the damage stability itself. You'll notice as it's going, it's actually running into some cases. Some of these cases, it's not even, it can't even calculate a damage stability for certain damage cases, which isn't a failure in this case, as it's a probabilistic approach. It just means that it's not getting any contribution from this damage case. But you can see in some cases it's failing calculations. But as it's gone through, you know, it's done my first 2 drafts. It looks like I'm ready on my third here. So going through and calculating things quite quickly. While it's finishing up, I'll notice, you know, this ribbon bar is shown a lot. We can actually add in things like tutorials. In this case, we actually have a SOLAS tutorial that will help you, as a first-time user of this, to kind of walk you through it. It's just a PDF document that we've included with the package that'll show up in the ribbon bar that you can access, that kind of helps you walk through the definition in this type of analysis. And then up here, we have a number of other things to look at. The main thing would be kind of the attained index summary. So here's kind of the overall pass-fail type of evaluation for this criteria. In this case, it's saying I need a total required of 0.693. I've only got 0.395. This was because I only did the one zone thing. So I think the actual design works better if you have the full number of damage cases defined. But you can do, again, this analysis template, this analysis package has a whole lot of things that are kind of built into it to look at, to help you in the design and the evaluation. Switching gears again, for those of you that have seen HexTab in the past, we do have a lot of the same salvage features and emergency response features in HexTab 9 as well. We are still working on bringing some of them over. So, for a lot of our salvage clients, we are still recommending that they stick with the version 8 software that they have now, just because it has been around for so long and it's well established at this point. But you can do the same type of analysis here in HexTab or in our version 9 software as well. So in this case, this would be a very basic, a very simple kind of salvage analysis where you start off with, you get the loading condition from the ship or something like that, saying, hey, here was our departure condition. And then maybe you define the burn off condition. So in this case, if I look at my changes here, all I've really changed is say, yeah, we went down to 50% on these tanks. And then I can add, I looked at raking damage or bottom damage. You can define the damage condition itself. In this case, like for a bottom damage, you can do things like you can in HexTab 8 to look at things like hydrostatically balanced loading and outflow, or setting things like that. And then I can do an actual stranding calculation. I can say that, yeah, the ship has hit a rock. It's sitting on a rock. It's damaged a couple of tanks, and it's hard aground. So in this case, we're calculating things like on the strength side, we can calculate what the force is at that location. You can see the corresponding strength and shear, has a big gap here where the grounding has occurred. If I look here in my graphics, you can see that, I've located the pinnacle here in this location. So that's what's driving the calculation. I can run tools to see, how things change over time as my tide changes. I have tools, basically I have a whole analysis package for stranding tools that gives me tools to define my one pinnacle grounding, a shelf of pinnacles. I can run a quick analysis to figure out what the tide would have to be before I was free. I can run a tide sequence itself. That's kind of what's been set up here on the this tide window. So you can say, as you can define a tide cycle and say, okay, if I'm already hard aground, what's going to happen as the tide goes up and down? Is there going to be more oil outflow? Is there ever going to be a case where the tide is high enough that I will float off? That type of thing. So again, all of the salvage and all of the stranding calculations, we are working on bringing them over from the older version of the software as well. There was one other calculation or one other approach that I wanted to look at. With this new software package itself, we've done a lot to allow it to interface with other modeling software. So this presentation, I haven't looked at the modeling side at all. And I think that a couple questions have been coming in on the modeling that have been answered on the side. The modeling software itself, we provide our ship project editor that allows you to define the 3D geometry, the hull, the compartments, and things like that. But there are obviously lots of other tools out there. So one that we've really been looking at a lot is Rhino, for example. So if I load up a Rhino model, if you feel comfortable doing 3D modeling in Rhino, we've made it so that it's very very straightforward, very easy to, don't update. Very easy to do your modeling in Rhino and send that model into HexSalve, into HexTab itself. So in this case, I have a very basic, rectangular barge. I've got a hull that's a poly surface, and I've got 4 compartments basically. Everything here is closed poly surface, closed solid poly surface. That's kind of the big key for us. As long as your model in Rhino has a closed surface, in this case, I'm showing you a deck tank we just added as a sphere just to show. But as long as I've done some basic modeling conventions in Rhino, i.e. closed surfaces, and if I do a little bit with my layers, if I add cargo tanks, so my cargo tanks, I basically have my 4 surfaces here that are defined in my cargo tanks. Rhino has a tool to just run a Python script directly in Rhino. So we actually provide a Python script that you can run in Rhino that will export a ship project. And as long as you have the model defined right, as long as you have the layers set up right, you can export a model, you can create a model automatically. We have this set up so it'll start HexTab automatically as well. So it can load that model, take that model in Rhino, export it into our format, and then I can work on that directly in HexTab itself. So in this case, I can see I've got my 4 tanks, I've got my sphere, I've got my hull. I could do an analysis on this guy starting right now. And then again, if I had a project already where I had set up an intact KG curve or something like that, if I made changes on my Rhino model, change the geometry, I could import that. All of my analysis would basically be the same. The setup would all be the same. I just have to rerun it to get the new result. So it should hopefully very quickly, kind of speed up that process on the design side of making changes to a design, making changes to the structure, reevaluating it, seeing what's good, seeing what's bad, going back, making changes, and going through that cycle as well. Whew. All right, I have touched on everything that I want to touch on, and we are at the end of the hour. So that's the end of the official webinar. I would invite any of you that want to stick around. We will stay on here for as long as possible to answer any questions you might have. If you want to pop them in chat, or I think there's an option to raise your hand if you want to. I can talk. I can give people access to actually ask questions if they would like. The question about importing and exporting GHS files. We can import a GHS model file. We don't support exporting to a GHS format. I'm not sure if GHS would import our files, though. That's, they're a bit of a competitor for us, so we don't want people going from our side to their side, but it is possible. We are, again, taking their models. We can take their models and run analysis on it. I would expect they could do the same on the flip side. We talked about other modeling items, MaxSurf, 3D models, DXF. Yeah, we can load all those pretty reasonably. There was a question about, can HexTab work with native CargoMax ship files and load cases? Absolutely. CargoMax, all of our software basically is built on the same underlying model, the SH2 file. So if you have access to a CargoMax model, you could take that and do a more detailed analysis in HexTab as well. If you have a cloud of surface points, can HexTab create frame curves? That one I don't think we could do directly. I think that would have to go through a kind of a process, either to turn that cloud point into a closed surface using something like Rhino or something like that, but it's not something we could take directly. There was a question, is it possible to pay for the HexSalve package specifically for a vessel on the offshore side? Generally speaking, no. The idea is that HexSalve is going to be generic enough that it should apply for any vessel. If you're looking at something from offshore or non-offshore, kind of, we have a HexSalve package for ships, and we have a slightly higher price for the offshore features. I think at that point it would be just as easy to upgrade to the offshore package itself. Rhino export, so do I have control over how to mesh the poly surface, right? The built-in meshing in Rhino, I believe, is usually sufficient for what we want, but I do believe you have some control over that on the Rhino side. I personally am not much of a Rhino expert, but I would I think that you do have control over that. Modeling in Rhino, can I name the tanks, give permeabilities, define deck lines, critical points? We are working on that. So I showed the very basic, the nitty-gritty way of the supported way, basically, of getting from Rhino into HexTab. We are actively working on a Rhino plugin that would actually allow you to do those things that you're talking about, to automatically set up the layers and everything so that the import and export can work correctly, and then doing things like naming, permeability, getting calculations directly within Rhino based on the HexTab calculation engine as well, things like that. We're also looking at tools like Grasshopper that would help automatically generate compartments where you can kind of visually, programmatically lay out how things are cut, how things are put together, and then have Grasshopper kind of do that automatically as you, even if you make kind of drastic changes to your model, it would automatically, if you changed your overall hull, it could, re-slice, recreate, recut all of your internal subdivisions as well. So it's definitely something that we're focused on doing moving forward. Yeah, there was a question on the cost of HexTab itself. There's a number of options. We're pretty flexible in the licensing, but generally speaking, we offer it in a one-seat single-user license, a site license, or a corporate license, which would be usable, by anyone in a corporation. And then it's kind of broken down for if you only need to ship portions versus if you want the offshore features as well. Looks like, yeah, if anyone's interested in knowing more, send us an email, or we'll send a follow-up as well. If you get a hull out of part surfaces with small gaps between the edges, can HexTab handle? I believe if there's gaps, it's not going to be defined as a closed poly surface. So that is one of the key modeling issues that we have is, and we've seen this as we work with other people's models, is that not everything is immediately a closed poly surface, and sometimes there's some repair, sometimes there's some tweaking or polishing that needs to be done to a Rhino model to get there. But that would all be done on the Rhino side. We basically need the Rhino model to be able to create the closed mesh.
Let's say something regarding that. That is true if you are importing from Rhino, but you can still define your hull through sections, even do that through Rhino and use the sections instead. In that case, you don't really need to worry about gaps between edges and so on and so forth.
Okay. How many compartments tanks can HexTab model handle? There is no upper limit. It's just going to impact, speed of calculation basically. But we've had models that have had hundreds of tanks and thousands of individual weight items, and it's all quite straightforward for the calculation. So there are no hard boundaries. There are no upper lower limits on pretty much any of the modeling capabilities. If you wanted to get down and get into the real nitty gritty and detail every nut, bolt, and cranny, then it's possible. On the licensing side, I also would like to point out everything is digital. When you purchase a HexTab license, you get a digital key that would be. You need to be online to register it or to activate it once. Well, once it's activated, then it doesn't need to remain online. It can be activated and deactivated any number of times, so it can be moved around. And we're working on making things a little bit more flexible for larger companies. But that's the licensing should be pretty straightforward for the most part. Well, if there's nothing else coming in here, I appreciate everyone coming in and sitting through this. I hope it was useful and helpful, and I hope pique some people's interest, this is going to be our kind of focus on development, focus for our company for the foreseeable future, and we're really excited about all the different ways and capabilities that it has, and we're just looking forward to having it grow and having the user base expand and seeing where it goes. If there are no other questions, I think I'll go ahead and shut things down. Thank you, everyone.